Well, howdy, y'all. 4.3. We're going to start messing around with how to graph things. We've really been building up 4.1, 4.2. Was the idea of, our increasing, decreasing, where the slopes equal zero, set derivatives equal to slope of their secant line. Now we're going to start messing around with like increasing and decreasing, uh, where we have slopes of tangent lines equaling zero, things we've already kind of built up to. But let's just start off with this first one. We're just dealing with the idea of increasing and decreasing. Now, shit. Y'all know what an increasing and decreasing part of a graph looks like, right? You know, when it slopes up, it's increasing. When it slopes down, it's decreasing. I know that's fascinating. But that's going to be kind of the game. So don't let the next little slide make you think it's anything different than that. So what we got here is for the idea of increasing and decreasing, we're going to say that suppose that f is continuous on a closed interval from a to b. That sounds familiar. And it's differentiable on the open interval from a to b. That also sounds familiar, like every other frickin' problem we've done in chapter 4. We need those two conditions to be true. Continuous on a closed interval and differentiable, smooth on the open interval. So what this is telling us is that if we have a positive derivative for each point in some open interval, well then shit, it must be increasing. You know, like a positive derivative would mean that we are sloping up. I'm sorry I keep using the word slope, but I'm trying to simplify it a bit. Now it's also telling us that if our derivative is less than zero at each point on some open interval, then we are decreasing on this closed interval. Now, this closed interval piece on the right hand side, don't stress about that. I don't really like this the way these slides have it. I'd almost prefer to keep it like this, but by definition, that's actually true. Just skip past it. Whatever. Do you know what increasing and decreasing look like? Do you have that concept? If I was to draw you up something like this and go like, hey, look, we got some sort of thing. Can you tell where the shit is increasing? Can you tell that we're increasing all the way up to like here, and then we're increasing all the way up to here, and then we're increasing all the way? You know what I mean? I think you can get that shit, right? So that's the idea with increasing and decreasing. But how the hell are we supposed to find intervals for it? So here's going to be our first kind of problem. Let's go through and let's see if we can't find where our function x cubed over 3 minus x minus 1 is increasing and decreasing. And the way we're going to want to do this is start off. We want to start by finding out where is f prime of x equal to 0. We're going to start with this. This is really anything through chapter 4. Taking a derivative, setting it equal to 0 and solving is a wonderful idea. This is going to create some sort of interval test. So I'm going to show you, and I'm going to talk some shit as we go through this one about, do you know what your graphs look like? Because sometimes if you know what the graph looks like, you're not going to have to do the end part that I'm going to do. So let's run through it. We take our function that was given to us, our f of x, which is equal to, oh, look how cooked up it is, the 3 up top, the 3 down below, to make it nice and simple. So we're going to take a derivative on this bad boy. So we're like, all right, cool. F prime of x is equal to the 3 falls and it cancels, just leaving us with x squared minus 1. Oh shit, that thing is cooked up. So we said we wanted to find out where is f prime of x equal to 0. Well, let's set that thing equal to 0 so we can find out where the hell it is. So here, 0 is equal to x squared minus 1. And we all know that's a difference of squares, or we can solve it. And we're going to say that x is equal to 1, or x is equal to negative 1. Cool, we found the two spots where we have a peak or a valley. We probably have a local min, or not even probably, we got a local min or local max hanging out at negative 1 and 1. Now, to figure out whether this thing is increasing and decreasing, we can do something called interval testing. Or you could just know what the frickin' graph looks like. Now, if you know what a cubic looks like, you remember college algebra and pre-calculus and all the other shit that you ever took in algebra? Yeah, it taught you how to do the basic parent graphs. So then you don't have to do all this bullshit at the end. I'm going to do this off to the side and just show you how quickly we could interval test this shit. It's a cubic with a positive. Right, when I keep saying cubic, third power, and it's positive, which means we know what the shape of the graph looks like. You spent a shitload of time in algebra supposedly learning this, which means we start in the third quadrant and we end up in the fourth quadrant, or the first quadrant. So maybe it does something like this. Well, shit, it can't come in from the top left and go down to the bottom right. That's impossible. So I already know where it's increasing and decreasing, just because I know the basic shape of the graph. I know that it's increasing from negative infinity up to -1, and then from 1 to infinity. I know it's increasing there, just because I know the basic shape of the graph. If you don't know the basic shape of the graph, now here we go. And this is what we call interval testing. Go through here and just take a look. Let's say for x is less than -1. Let's say when our x is trapped between -1 and 1, and let's look at when x is greater than 1. So what we're doing is we're actually taking some boundaries here. Right? X is equal to -1 and x is equal to +1. My bad. At these boundary points, right? Because look at the graph I have over on the right here. Now, if you have that there is a slope of 0, that means we must be changing, right? It must be going from a positive slope down to a negative slope. At some point in time, it's changing. Now, it doesn't have to turn around, but what's going to happen is if there's only one spot to the left of -1, now it's either increasing or it's decreasing. You have no other freaking choice. So what we're going to do is we're going to take a test point. Do you know a test point, a number that's less than -1? Maybe we check out x equals -2, right? That's smaller than -1. And then we just pop it into our derivative. F prime of -2, and we check it out. We just want to see, and we don't care what the number is. I don't give two shits what the number is. We plug that thing in. What would we get if we plugged in -2 into this one, right? What, -2 all squared minus 1, that equals 3. So I'm going to write this thing in. That's what we cared about. Isn't 3 positive? Isn't 3 a positive number? It is a positive number. So shit, we found out that we are increasing from -infinity up to -1. Now let's check our boundary points between -1 and +1. Let's check some numbers. Now you're going to choose a half. You're going to choose -3/4. Or maybe you're going to choose 0. You know what I mean? Let's check 0. Choose the easiest freaking number possible. So let's check out when x equals 0. What's going to happen to our derivative? What's f prime? We're going to look at what's f prime of 0. Interval testing. So now we're just going to plug in that 0 right into our derivative. 0 squared minus 1 equals -1. Don't give a shit what the number is. Isn't -1 negative? So we have found in between -1 and +1, we have a negative. We have ourselves a negative derivative, which means we are decreasing. Lastly, we're going to plug in +1. We're going to check this sucker out. Or shit, you can plug in, not +1. We're going to look at values larger than 1. I could plug in I could plug in 1,000. But I think maybe the easiest way of doing this is just x is equal to +2. So we get 2 squared minus 1, which is still equal to 3. Don't give a shit what that number is. All we care about is whether it's positive or negative. And we have now found out that we have a positive slope. Therefore, to answer our question, what it was asking us, where is our function f of s increasing and decreasing? Well, we can state that it is increasing on the interval from -infinity up to -1, right? From right here, just saying it's positive, huh? And then we also have another one saying that when x is greater than 1, we're also going to have a positive derivative. So we have another interval. Remember that u thingy we used to use back in the day? Remember that, like math D shit? It won't come to infinity. And now we just write down that it's decreasing on the interval, and it's only decreasing between -1 and +1. And there it is. We have now found where this is increasing or decreasing. We're going to have a lot more fun with these types of problems. This is just the beginning. We're going to go through. We're going to start talking about concavity. Oh man, you're going to really know how to graph after this. I'll have a fun-filled graph for 4.5 because I don't teach 4.5. I have you teach yourself through this one. So this is perfect for online environment. So wonderful, wonderful, wonderful. I will see you in the next one.